All right, so far we've learned about compounds and how to figure out the molar mass of compounds. We learned how to go from grams to moles to molecules, which is like going from grams to moles to atoms, except for we're dealing with molecules instead of atoms. Now what we're going to do is we're going to take it a step further, because we're going to be able to go from grams to moles to molecules, and then we'll be able to go from molecules to atoms. And what I mean by that is, let's say we had 10 molecules. 10 molecules of calcium bromide, let's say. How many atoms of bromine do I have? Well, for every one of these, there's 2 bromines. So that means if we had 10 molecules of calcium bromide, we would have 20 bromines. And so notice how we went from molecules to atoms. And the way that we do that is we essentially multiply the number of molecules by the number of atoms. So let's go ahead and take a look here. Now, let's go ahead and go over the types of particles. Atoms are single elements. Ions are charged elements or polyatomic ions. So essentially they're atoms that have gained or lost electrons, or they're groups of atoms that have gained or lost electrons. Then we have molecules. Molecules are covalent compounds, and then we have formula units, which are ionic compounds. And so you can see the examples to the right there. Now, when we are given a molecule or a formula unit, molecules and formula units are dealing with multiple atoms, multiple types of elements. And we can go from molecule or formula unit to individual elements. So for example, in this situation here, we went from this formula unit, 10 calcium bromides, to 20 bromines. And the way we do that is we can think about it in terms of moles. Notice this compound here. This is 1 magnesium to 2 bromines. And so for every one of these, we have 1 magnesium, and for every one of those, we have 2 bromines. And we can actually think about it in terms of moles. If we had one of these, if we have 1 mole of that, we would have 1 mole of magnesium and 2 moles of bromine. Because again, for every one of these, there's 2 bromines. So if we had 2 moles, or if we had 1 mole of this, we would have 2 moles of bromines. And the fraction we would use is we would end up having moles of MgBr2, and then we go to moles of Mg. For every one of these, there's 1 of those. Or we can go from moles, again, of MgBr2 to moles of bromine. And in this situation, for every one of these, there's 2 moles of that. Now we can do the same thing with this, and this is dealing with a polyatomic ion. And if you take a look here, how many NH4s are there? There's 2, because the 2 on the outside of the parentheses tells us we have 2 of those. So if we have 1 mole of this, we would have 2 moles of this. Again, if we had 1 mole of that, we would have 1 mole of CO3, because how many CO3s are right there? There's 1 CO3. So in this situation, we would have 1 mole of NH4,2CO3 would be 2 moles of NH4. Likewise, if we had 1 mole of NH4CO3, then we would have 1 mole of CO3. Because again, for every one of these, there's 1 CO3. So let's go ahead and go through a couple practice problems here. Something that I really want to highlight is before we would have grams, moles, and what was here was atoms. Now we're dealing with not atoms but molecules. If a problem ever gives you atoms, it doesn't give you a molecule. For example, this is giving us a molecule. But if it gives you just atoms, like carbon atoms, then you treat it like we used to treat it before, where we would go from grams, moles to atoms. However, if it gives you a molecule, and then it's asking for atoms, so it's asking for moles of a specific element, this is where we have to do something a little bit different. This is where we need to go from, if we're given grams of molecules, we need to go to moles of molecules, and then we can go from moles of molecules, we're going to add a little part here, to moles of atoms. And so again, this right here is going to be moles of molecules, but we're going to go to moles of atoms. And the way we're going to do that is we're going to use this concept right here where we know 1 mole of a certain molecule has a certain number of moles of that atom. So let's go ahead and give this a shot. So we have 3.56 times 10 to the 24 molecules of tricarbon, okay, so tricarbon tetrahydride, which is this. And it's asking for moles of carbon. So we're given molecules. We have the number of molecules, and we need to go from molecules to moles of the molecules. And so, forgot to put MLC here, so molecules. So we have molecules of C3H4, and we're going to go to moles of C3H4. We know that 1 mole is 6.02 times 10 to the 23rd. Now, we see that moles of molecules, molecules cancel out, and now we're left with these moles here. And we know, I'm going to go ahead and write this down here. You can find other space to write it if you want. So we know that 1 mole of C3H4 is going to have 3 moles of carbon, because this here tells us how many moles of carbon there will be in 1 mole, because again, for every one of these, there's 3 carbons. So if we had 1 mole of this, we would have 3 moles of carbon. And we can use this conversion factor here to go from moles of C3H4 to moles of carbon. We go from moles of C3H4 to moles of carbon. Notice how these cancel out, and we know that for every 1 mole of this, there's going to be 3 moles of carbon. And so all we need to do is type this in our calculator, and we will get our answer. And when we type this in the calculator, we do end up getting 17.7 moles of carbon. All right. So let's go ahead and go on to this next one here. It says, how many nitrate ions are there in this many moles of gallium nitrate? Well, gallium has a 3+ charge. Nitrate is NO3 1-, and the way you figure out what nitrate is by looking at your polyatomic ion sheet. So notice how it has a 1- charge. And so if it has a 1- charge, that means it is a 1 to 3 ratio. And so I'm going to go ahead and write that there. So we know it's a 1 to 3 ratio. So it's going to be this, where it's gallium. Now nitrate is NO3, so we have to put NO3 there. But again, it's a 1 to 3 ratio, so we should have 3 nitrates. And so that's going to be how many, or it's going to be our formula there. Now notice for every one of these, we have 3 nitrates. So that means for every 1 mole of this, we have 3 moles of nitrate. And so if we have 0.14 moles of the gallium nitrate, we can go from moles of gallium nitrate to moles of nitrate. And we know that 1 mole of this has 3 moles of the nitrate. Now, once we have moles of nitrate, we can go from moles of nitrate to ions, because we know that 1 mole of anything is 6.02 times 10 to the 23rd of that thing. All right, and then we just type that in the calculator and we'll get our answer. And what we end up with is 2.5 times 10 to the 23 ions of nitrate. So just to recap, again, we know the moles of gallium nitrate, and we go from moles of gallium nitrate to moles of nitrate. And once we know the moles of nitrate, once we know the moles of anything, we can figure out how many of that thing there is, because 1 mole of anything is 6.02 times 10 to the 23rd of that thing. So again, 1 mole of anything is 6.02 times 10 to the 23rd. And so in this first step here, we are going from moles of the compound to moles of the ion. And then once we figure out the moles of the ion, we can then go to how many of those ions that we have. All right, now this next problem here, we're going to be starting with atoms, and we're going to the formula unit there. And so it's asking how many moles of aluminum oxide are there, or how many moles of aluminum oxide contain this many atoms of aluminum. And so aluminum, if you look on your periodic table, is a 3+, oxide is a 2-. This is a 2 to 3 ratio. So to balance those charges, it's a 2 to 3 ratio. And so we have 2 aluminums, 3 oxygens. And so that's the formula there. And I'm going to write this over here. All right, so we're given 3.7 times 10 to the 23rd atoms of aluminum. And we can go from atoms of aluminum to moles of aluminum. And then we can go from moles of aluminum to moles of aluminum oxide, because we know that one of these has 2 moles of aluminum. We also know that 1 mole of anything is 6.02 of that thing. And then all we have to do is type that in our calculator and we get our answer. And what we end up with is 0.31 moles of aluminum oxide, considering sig fig. So again, we have our atoms of aluminum, and we go from atoms of aluminum to moles of aluminum. And then once we know the moles of aluminum, we can go from moles of aluminum to moles of aluminum oxide, because we know that for every 1 mole of aluminum oxide, there's 2 moles of aluminum. And then we can just type in the calculator and get our answer. So go ahead and do the practice problems on the next page, and check the key for the answers. And if you have any questions, feel free to email me. Have a great day.